To keep the disease at bay, the worst affected countries can't afford them.
These chimps were once part of the American space program, and one of them, called Marilyn, has made history by providing the final piece in the 20-year puzzle on the origin of AIDS. The chimp, who died in captivity 14 years ago, was found to contain a new strain of virus that's almost identical to the main HIV virus found in man. The announcement was made in the United States early this morning.
Chimpanzees, as you know, are 98.5% genetically identical to us. So here is a species very closely related to us, basically infecting with a very similar virus that doesn't get sick.
This is the species of chimpanzee that's thought to be the source of the AIDS epidemic. It's long been known that the disease spread to man from monkeys or apes, but now it's been narrowed down to this one type of chimp, which is hunted and eaten as bushmeat in Central Africa. In the early days of AIDS research, hundreds of chimps from labs like this at an American Air Force base were deliberately infected with the HIV virus to see if they developed AIDS. Surprisingly, they didn't, and one of the British researchers involved in the team says there's now an urgent need to explain this anomaly.
For the same virus to cause disease when it's in one host, the human, but not in another host, the chimpanzee, gives us an opportunity to conduct further research to find out why is there that difference. If we can find out why there's that difference, then perhaps we're one step further along the way to finding out how to combat AIDS.
But not every scientist is as optimistic.
There have been just 4 cases discovered, all chimpanzees in captivity, and we still don't know what's really going on in wild animals.
The scientists behind the research want further studies on chimpanzees in the wild, but discovering the origin of AIDS, which affects around 34 million people worldwide, will provide an important clue for developing a vaccine. Sue Nelson, BBC News.
And Dr. Sarah Rowland-Jones from Oxford University has studied HIV immune groups in Africa to help develop AIDS vaccine. She joins us now live. What is the importance of this?
It's a very exciting piece of research which finally puts in that missing piece in the jigsaw to explain how HIV came into the population. And as the people that you've interviewed have just described, the key thing now is to understand how chimps have been able to live with their form of the AIDS virus and not get sick, whereas HIV has such devastating effects on the people it infects.
And how might that then lead to scientists being able to develop a vaccine?
Well, we need to know really whether the control that the chimps have over the virus that infects them naturally is through immunological mechanisms or through that very small part of their genetic material that's different from ours. So getting a handle on that will give us some clues either towards therapy or towards a vaccine development.
Because there are, of course, some very small groups of human beings who seem to have developed some sort of an immunity, and presumably you would make comparisons with them.
Yes, I think there are both people who have, like the chimpanzees in the wild, been able to live for many, many years with their virus, with HIV infection and not become sick. And we've also been interested in another pretty rare group of people, people who get exposed to the virus every day, and these are largely sex workers working in slums in Africa. And these are people who, despite getting exposed day after day, never apparently get infected with the virus, and these too have built up some kind of immunity to it.
But briefly, the possibility of discovering a vaccine. I mean, there are treatments, of course, for HIV, but nothing that could come close to stopping people actually developing the disease and suffering from it. We are talking about the possibility, how far down the road of a vaccine actually becoming available that stops people getting AIDS? Well,
there are a number of vaccines being tried now, which we hope will be tested in the countries that most need them, and we in Oxford are involved in that kind of research at the moment. So there's still a few years of work to go, but it is at least feasible.
Dr. Rowland-Jones, thank you very much.